Hey guys, so let's go over homework from 2.6. So pull that out. You had 6 questions that just talked about, do you understand that there's a relationship or not? And you have a lot of these in Khan Academy as well, so not a whole lot of homework last night. 3, 4, and 5, where can you tell that this is close to a line? If you were to draw a line, it might be here, and it goes down, so it's negative correlation. 4, if you were to draw a line, it'd be somewhere here, and it would be positive correlation because we're going up. And then here, I don't know how to draw a line, so there's no correlation for 5. 6, I randomly skipped, so let's talk about 6. They asked, if you don't graph it, how can you tell whether it's positive or negative correlation? So if you look at a chart of values, and as x goes up, if the y values also go up, then it's going to be positive correlation. But on this other problem, we did number 15. As x gets larger, so it goes 16 to 24 to 68, x is obviously going this way. The y values start at 3.9 and end at 2.6. They go down. So this would be negative correlation. Then on 7, 8, and 9, you were asked to estimate, and you weren't given really small numbers to estimate. You're just talking about the big idea whether there's correlation or not. This first one was just a cloud of dots, so it's r equals 0. Here, my drawing's not all that great, but there is a sort of positive slope to this, and it's off the line, so I would call it 0.5. And then number 9 is much closer in the book. If you looked at it, it's much closer to the line, so I call that -1. Definitely between those two, this is closer to 100% than this one. Maybe I would have called this -0.9. 14 and 15, these were the hard ones. So I'll look at your homework and kind of give you some feedback if your drawing is not all that great. But here's the idea for 14. You're given some data. They don't tell you what the data is about, so you really don't know that information. But they give you some x values and a y value and some y values, and you're supposed to graph them and then make some conclusions. So the hard part about this, and I found this in the other Algebra 2 class, is that some of my students will draw this out, and they might start here at 120. So they might draw it with a little tiny graph that says, let's start at 120, and then go 130, etc. If you do that, when you draw your line, this distance is 120, and this distance is just 10. So you cannot figure out what the y-intercept is there. So I had to draw a real drawing that had as much to scale as could be possible for me to estimate or model the line that goes between those values. So, I mean, it's not perfect. It's still a sketch, but I counted 1, 2, 3, 4, 5 up to 9. Because my values went from 5 point something up to 9. And then these values just depended on my paper. I decided to go up by 20. So yours may look a little bit different than mine. And of course it's a sketch, so you and I probably do not have the same slope. But what I'm looking at is, did you draw a neat graph? Did you try to estimate the best points that you could? And if that's true, then when you try to draw a line through those points and all the way to the y-intercept, then you have, as best as you can do, a model. That line is a model of the data. So first, I wrote this down. Next, I drew my domain and range based on that chart. And then I went and plotted my dots. I found something straight, and I drew my line all the way to the y-intercept. And I guess that is about 10. Maybe it's really 8. I'm not really sure. If I was trying to be exact, then I would definitely pull out some rulers for every direction and graph paper so that I could be very, very specific. So for this data, we're looking for a close estimate. Anyway, then after that, I tried to find dots that were on the line. to see. So I guess that this was here. I guess this was about 10, 0, 10. So I included that point, 0, 10. And I found this one over here that looked like it was about an 8. So I used these 2 points, 8, 160, 8, 160, and 0, 10. And that's where I found my change in y over change in x. So I subtracted 160 and 10, and then 8 minus 0, and that gave me this crazy slope, which is 85 over 4. And then I'd already found my y-intercept, this 10, and that gave me my equation. Y equals, or f of x equals, the slope times x plus 10. After that, they said, hey, what do you think will happen when you go past 9 and go all the way to 20? So my estimate says plug in 20. That's this new function notation we've been talking about. It means exactly this function when we plug in 20. So I rewrote it, 85 over 4, my slope, times 20, plus the 10, just this equation, but a 20 here. And I found that I would have a point at 400, so it would be way up here at 20. Somewhere you can't even see where I'm pointing, way up here if I went to 20. So that's my estimate at 20. Yours is going to be different. But this level of inaccuracy, if you will, is definitely doable by everybody in class. So for future, you might want to go try to draw this yourself and see how you do. Because it's definitely within your means to estimate the points and try to draw a straight line through them. 15 was a little bit different because the numbers got big in the other direction. So for 15, they got big in the x direction. So I wrote down my chart and I plotted my points as best I could. Here they are in pink. I drew a straight line through them, and then I estimated this to be about 4.5 was going to be here, so I said that was 4.3. That's right here. This is my y-intercept. And then again, I tried to find points that were near values that made sense. So 10, 4 is a value on my line. I'm not looking for points that were given to me. I'm trying to write an equation for the line. So it doesn't matter to me where the points are. The points could have been up here and down here, and I'm just drawing a line through it. I'm looking for slope through points on the line. I also found this one that looks like to be about 45, and then this was in the middle, right where I had graph 3. So those are my 2 points. I used those 2 points right here for slope, y minus y over x minus x. I got this for slope, which makes sense. It's negative. This definitely goes down, and it goes down a little bit and then a lot for the x value because these were bigger numbers. So down 1 over 35 is my slope. I put it in my equation right here. I put in my y-intercept, and then I tried it at 20. So this little notation is similar to the function notation, but it tells everybody, hey, this is what happens when I plug in 20. So we call that y sub 20. I plugged in 20 and I got this, and I threw it in my calculator and got 20, 3.6. Now 20 is actually on this graph. So 20, if I go back and look at that, 20 on my line is here, and that's probably a pretty good estimate. So it would be about 3.6. That's pretty, oh, you can't see it. I'm so sorry. Let me try that again. It was 20, so here's 20. I drew a little dot, and it's probably here, which is close to 3.6. It's a pretty good guesstimate for that. So drawing your graphs takes a little bit of practice and thinking about, there's some planning involved. So you have to look at the x values and go, they're pretty big. How am I going to count them out? These values are small. I need to count them differently on the y-axis. You do have to plan in order to write out your graph. You can't just go 1, 2, 3, 4. You'd never make it to 70. Okay, so these were homework questions. If you still have homework questions and these did not answer it, please send me a comment on that post so that I can go back and look at that and make sure that you are square with 2.6, the draw scatter plots and the best fit lines. We're going to go on to 2.7 today. And as a reminder, back on those scatter plots, you have some Khan Academy. It's due on Friday, so please do that. We're going to look at absolute value functions today, and they are really fun to graph. Absolute value functions. We talked about absolute value a little bit already. Absolute value has these bars right here, which indicate distance from 0. So we talked about if here's 0, if we walk 5 paces this way up to +5, our GPS would say 5 steps. If we walk backwards, 1, 2, 3, 4, 5 to -5, the Garmin watch is still going to tell us we walked 5 steps, but we walked in the negative direction. So it's not really negative on the watch. Absolute value says you walked 5 steps. That's the distance away from 0. So numbers that come out of absolute value are always positive. So absolute value bars. Bars. Guarantee a positive outcome. So we're going to learn to graph these today. These are like linear functions, but they're not linear. They have a different shape. And we're going to start graphing them with an XY chart. So y equals the absolute value of x is the parent function. That means it's the most simple function that there is for this type of function. So we're going to call this the parent function. And we're going to learn how to translate those back and forth in order to see how they translate with more complicated functions. So let's start with an XY chart. We have X and Y, and we're going to plug in, this is what we did in the summer packet, we're going to plug in values around 0. I started my XY chart from -3 up to +3. I'm just going to do whole numbers because that'll be easy. So for all of these, you might be able to do them in your head. I'm going to write some of them down just so they make a little bit more sense. Let's say that we have the absolute value of -3. So I'm plugging -3 in here. I'm going to figure it out. So the absolute value of -3 is just like this distance. It's going to be +3. The absolute value of -2 will be +2. Absolute value of -1 is 1. Absolute value of 0 that's not really positive or negative, but it remains 0. We didn't go anywhere. It's a distance from 0. 1, 2, and 3 are already positive, so they remain 1, 2, and 3. So we have some repeating values here, but this is still a function because -3 only returns one output. It's okay to have the same output for two different numbers, but not the same number. When we graph it, we end up with this cool shape, which is -3, 3 is here, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, and it's going to do this for everything in this direction, and then it's going to go like this for everything in the negative direction. So absolute value graphs are always a V shape. So absolute value functions are V-shaped. And we're going to make skinny V's and tall V's, move them around so they don't always have the same starting position here. But let's talk about this one that we have. So this one that's graphed, we're going to call this point the vertex. It's the point at which the graph changes direction. We could also call this the minimum value, which is also the point at which our function changes direction. It's the lowest point in this neighborhood of points. Our vertex for the parent function is 0, 0. Same for the minimum value. I said before that absolute value is like a linear function. The difference is that since absolute value changes all the inputs into positive outputs, we actually have two different slopes. If this had just been y equals x, it would have been a straight line all the way through and not changed direction. But this is absolute value, so when it reached 0, it wasn't negative anymore and it started going up. So what's interesting about this is that on one side, this has slope of positive 1, and on the left side, it has slope of negative 1. So when we solved these and they had two equations, so y equals x and y equals negative x, those are the slopes right here. So if we were to solve this, we'd say y equals x and y equals the opposite of x, so we'd have this negative slope. So this is the parent function. This is what it looks like. Let's take a look at what happens when we change some things. So let's do another by hand, and then I'm going to use my calculator and show you some different things. So my second example, let's do y equals the absolute value of x minus 2. So this will also be a V-shape. Simply knowing that absolute value is a V-shape is helpful. I also know that this is going to be an up V, which we're going to talk about in a minute. And I have some shift here that I'm not sure I know where it goes, but we're not sure where it goes. So let's do another XY chart to just practice plugging in our numbers. So this time let's start with, we'll start with the same values. We'll just do -3, -2, -1, 0, 1, 2, 3. So we'll do all the same values. And we're going to plug them all in. We do not take we do not make it positive until we've done the math on the inside. These work like parentheses. So they're not there, but we have to do the work inside of here before we make it positive. So over here, I'm going to write it out. It's the absolute value of x minus 2. I'm going to plug in each one of these values. -3 minus 2, that's going to be -5, which is really little. I should have made that larger, sorry. Absolute value of -5 is +5. I'll make this one better. Let me make some room. Okay. Then I have the absolute value of -2 minus 2, and that is -4 inside the absolute value. -4 absolute valued is 4. Then I have -1 minus 2, that's going to be -3. That's going to be +3. 0 will be 0 minus 2 is -2. You can probably see a trend here, but I don't know where it's going to turn around, so I just want to make sure I do these right. 2. I'm going to plug in 1. 1 minus 2, that's -1. Its absolute value is 1. 2 minus 2 equals 0, and that's 0. 3 minus 2 is 1, and it's an absolute value, but it's still 1. And then the positive numbers are just going to start to go up again. So real quick, I could add a 4 here and say 4 minus 2 is 2, and 2 is already positive, so I can graph that. So let's see what this looks like. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay. Oh, I need a 5. There we go. So all these points, I'm going to graph them. -3 up 5, -2, 4. If y'all need to pause this and then catch up if you're writing stuff, since I already have an idea of what's going to happen here, if you want to pause it, come back, that'd be fine. You can pause it and graph all your points, and then I'll catch up with you. -1 is 3, 0 is 2, 1, 1, 2, 0, 3, 1, 4, 2. And that's enough for me to see the V. I can draw in the graph from here. So it's going to go up here. It's going to go up there. So my vertex has moved. It was at 0, 0. This would be the parent function. It has the same shape, or it should. My new vertex is 2, 0. I still have a slope of 1 and a slope of -1. This is going down, this is going up. But I change by 1 every time, so it's the same. So this had a right 2 shift compared to the origin. The origin was at 0, 0, and this went right 2. Okay, and we're going to do several graphs on the calculator in just a minute so you can see all the different translations. All right, I've got my calculator up. For right now, I don't want you to play in your calculator. I want you to just watch what happens, and we'll take some notes. When we're together again in class, I will let you play with the absolute value functions on your calculator, or you can certainly do that with your homework tonight and check your work. So right now, I've already put in several absolute value functions. Only this first one is going to graph right now because it's the only one with the equals dark and highlighted. So that's the regular absolute value function, the parent function. This is the one we just graphed by hand, x minus 2. It shifted to 2 over on x. So what do you think is going to happen with x minus 5? It's similar to x minus 2. It's probably going to shift to the right 5. And so in green, we have 1, 2, 3, 4, 5. It shifted to the right 5. So if they said minus 2 or minus 5, they shifted to the positive side. So we can probably guess that turning this one on, x plus 5 is not going to be at plus 5. It's going to be on the other side. So here it is at -5. So that's kind of pretty. Let's write down all those different ideas on our paper. Okay. So we graphed y equals x in absolute value, y equals x minus 2, y equals the absolute value of x minus 5, and y equals the absolute value of x plus 5. And this is the parent. This one moved right 2. Okay, and then this one also moved right, but 5, and this one moved left. So what do you think y equals x plus 9 will do? There's definitely a pattern here. These two moved right, which is in the positive direction. This one moved left. I'm going to guess that this one's also going to move left in the negative direction. So I'm going to guess that this one is going to be at 1, 2, 3, 4, 5, 6, 7, 8, 9. Just draw through there. I'm going to guess it's going to be right there. Let me graph it and see what that looks like. So I'm going to turn all these off so that we can tell what's happening with my special graph. Might as well just use this one. So x plus 9 was my graph, and here it goes. There it is at -9. So let's make a rule that goes with that. we're going to say that in the parentheses with x, I know these are absolute value, but they act like parentheses. And that with slash, W slash means with. In parentheses with x, we have opposite math. That means that if it says plus 9, it's really going to do the opposite. It's going to go negative 9. If it says plus 5, it's going to go opposite math to negative 5. This says negative 5. Opposite math is positive 5. So write 5 in the positive direction. And the reason for that is because if you were to solve something, say you had this, 0 equals x plus 9. If you solve that and said, what's the x value? The x value that would make that 0 is negative 9. Because if we move negative 9 over here, we have x by itself and we have negative 9. So in solving this tiny equation, it helps to explain what happens with x plus 9 being here. We're looking for the value that makes this 0, and that value is x equals negative 9. Let's look at some more translations with our graphs. Let's look at the parent function, and then this time let's compare y equals the absolute value of x plus 2, y equals the absolute value of x minus 5, and see what happens. I'm going to graph those in the calculator, and we will make plans for those translations. In the calculator, I have the parent function and the x plus 2, absolute value of x plus 2, ready to graph. So it moved the vertex up 2. So it's the same. Here's the equation, x plus 2. It moved it from 0, 0 to plus 2. Let's go and turn on this equation for 4 and graph it. And the one that says negative 5 is down here at negative 5. So for the y equals part, this was at 0. This one is at negative 5 for y. So the values on the outside of the absolute value, they relate to y and they're real math. So they don't change. So this plus 2 means up to from the parent function. And this negative 5 means down 5 from the parent function. So taking both of those into consideration, let's look at y equals the absolute value of x plus 2 minus 3. And with this example, let's guess what happens. This one is opposite math. This is going to move it left, right, because that's what x does. X is on the left, right axis. It's going to move it not plus 2, but it's going to move it left 2. It's going to move it in the negative direction, opposite math. This is going to be same math, or real math. This is going to be down 3. So I'm going to guess that our vertex is at left 2, negative 2, opposite math, not positive 2, and real math, negative 3, my vertex is going to be there. Let's graph that and see what it looks like. Okay, here we are. We have x plus 2 minus 3. We're suggesting that it's going to be at negative 2, negative 3. Negative 2, negative 3. So we're going to make some rules to deal with that. Let's also look at what happens when we have a negative in front of the absolute value. That's going to take every value that we put in. We're going to put it in here. It's going to be positive, and then we're going to turn it negative. So let's see what that does to the graph. That makes our graph go down. So that's pretty cool. It still has a slope of positive 1 and negative 1, but they have flipped sides. One more translation we want to do is right here. What if we had it be positive 2, I'm going to take this out. Oops, I took too much out. Let's try again. 2 times, here, I'm going to go back. I'm going to do the parent function so you can see what will change. Here's the parent function. Let's make it something interesting. Let's make it 3 math absolute value x and see what happens. The blue is the parent function. The 3 is the red. So the parent function has a slope of 1. And if you look at the red, it has a faster slope. It's up 3 over 1, up 3 over 1. And then on this side, it's down 3 over 1. So it's still plus or minus 3 here. So this 3 stretched our graph. It stretched it. It made it grow faster because it has a 3 here. Every number is multiplied by 3. Let's do the same thing, but let's use a smaller number. Smaller number, it should grow slower. So instead of having this slope, it's going to grow slower and be down here. So let's put in 0.5. So for that means a half. Math, absolute value, I'm having trouble there. And then x. And it's going to grow slower. It grew here. So this is the parent function that has a slope of 1. This is a slope of 3, and this is a slope of 1/2, that number in the front. Okay, let's take all of this and make some rules about it, and then see if we can do some graphs for homework. So our general rule is this. So this is for general, all absolute value graphs. Okay, absolute value graphs. Here's what they look like. Y equals, and I'm going to have some numbers that represent any graph at all. I have these 4 different things that could change my graph from the parent function. This negative in the front, and I could make it positive or negative. There we go. The numbers in the front, positive means it will be an up V. So positive means it will go up, and negative means it will go down. It flips all the values and sends them down. This A here, A is the stretch or shrink. It changes the slope. So it takes a graph, and if it was a V like standard, if you make it a big number, it's going to be stretched up. It grows faster. And if it's a small number like a half, it would grow slower. So what we're saying is that if the A value is bigger than 1, it will be stretched. We can also consider that to be like a skinny graph. You can see the skinnier one up here. This has A greater than 1. But then, if we talk about A being a fraction, say A is between 0 and 1. So like a half or a third or 5/8, any number that's a small fraction, then it would be this graph, which is a shrink. You can imagine the whole graph kind of getting shrunk. And it's going to be more like a fat graph. So this is going to be A between 0 and 1. Then we talked about H. This is opposite math. That's why there's a minus here. So the minus, that's opposite math. And it moves our graph left or right. The last value is K. It's the horizontal shift. It's on the outside like Y. This is on the inside like X, so it affects X. K is on the outside like Y, and Y is up or down. So this is the vertical shift. So it goes up or down with those numbers. So I'm going to need you to put that somewhere for your homework so you can reference it. Let's look at 2 examples for class for right now and be able to tell what's happening with this graph. So I'm going to say 3/4 absolute value of x plus 2 minus 10. Oh, I'll say plus 10. We'll put some pluses in there. So this is an example, and I have not graphed it. I'm not going to put it in the calculator. I just want to talk about all of these things from the general equation of an absolute value graph. And there's 4 things we're going to do. We're going to first start with the minus. The minus means that this is going to be a down-shaped V. Takes whatever value we have and then it makes it negative. It's going to end up going down. The stretch or shrink, this is the slope. So this has a slope of 3/4. It's smaller than 1. This is going to be a fat graph. It's going to be shrunk. Shrunk. It's going to have slope of plus or minus because a V has a positive slope and a negative slope. This 2 is opposite math. So it's going to shift left. When we think about the XY axis, X goes left and right. And in the left direction is the negative number. So this is left, and this is right. This is negative, and this is positive. But we're doing opposite math. It says plus, so we have to think of it as minus 2. So left 2. And then the 10 is on the outside like Y. It affects up or down. For Y, it says downy, but this is a big Y, okay? And this is going to be regular math. So same math is going to be plus 10 or up 10. It's a weird 10 there. That makes my vertex right here. Vertex is going to be -2, +10, and we could graph that on our own really quickly. 1, 2, and then up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And it has a slope of 3/4. My usual slope is a 1 slope. It's 45 degrees. That's the parent function. My graph is going to be in pink, and it's going to be fatter. It's going to grow down 3/4. So it's going to be fatter than this standard graph. So this is the graph right here. And the blue one is y equals absolute value of x, the parent function, so I can compare them. So some of your homework is you comparing them.